welcome back to my channel. Today we will discuss on chapter 5, work, energy and power. So in this video, we will continue discuss subtopic 5.1, exercise 2. So exercise 2, questions number 1. You push your physics reference book 1.5 meter along a horizontal table with a horizontal force 5 Newton. The frictional force is given 1.6 Newton. So they ask you to calculate the work done by 5 Newton force. This is actually the external force, the frictional force, weight, and also normal force. So we need to calculate work done each of the forces. Okay, so the first one, force for the external force. Okay, so external force F external S cos theta. Okay, so before that, you need to draw out first. For example, let's say this is table and this is your book. Okay, this is your book. So this book actually experience 4 forces, where the first one is they are weight, normal, okay, and there is a pushing force, okay, to the right, and because the motion is to the right, the motion is to the right, so therefore frictional force is in opposite direction, so it will acting to the left. Okay, so we have 4 forces. There's no tension because there's no string. Okay, so the first one, F external. Okay, F external is to the right. Okay, and the displacement also to the right. Okay, so F is to the right. This is F external, and the displacement also to the right. So we substitute into F external is 5. The displacement just now is 1.5 meters, so we substitute 1.5. Cos, because they are parallel, so it's cos 0 degree. So therefore, we will get 7.5 joule. Okay, next we go to frictional force. So work done on frictional force. So of course here we must substitute frictional force times displacement cos theta. Okay, so it's given frictional force is 1.6. So we substitute 1.6. Displacement is equals to 1.5. So cos. So you must draw out, okay, the directions, the angle between them, where your friction is to the left and the displacement is to the right. So the angle between frictional force and the displacement is 180 degree. So cos 180 degree, you will get -1. So therefore our answer is -2.4 joule. Okay, so negative here shows that the work is done by or done on the system. Okay, just now in the first video we already mentioned when you get negative, okay, when the answer negative, meaning that the work is done by the system. Okay, this is the work is done by the system. Okay, work is done by the system. Okay, next one is weight. So work done on gravity, so it's equals to mg. Displacement cos theta. So mg here, they give us the weight. So in these questions, I found that there's no weights given. Okay, so but never mind. Okay, we just write mg. S is 1.5. Okay, so cos, because our weight is acting downward, S is to the right, so the angle is 90 degree. So therefore our cos 90, at the end you will get 0 joule. Okay, so even though you don't have mg also never, because the final answer you will get 0. Okay, similar for normal force. Okay, normal force S cos theta. So normal force also is not given because mg also we don't know. S is 1.5, and again normal is upward and the displacement is to the right, so the angle is 90 degree. So cos 90 you will get 0, so you will get 0 joule again. Okay, so even though you don't have a normal force also never mind, because at the end you will get 0 joule. The answer is 0 joule. So next one, B. They ask you to find the total work done. Okay, so total work done, of course, we must total up all the work done, okay, including the external force, frictional force, normal force, and also the weight. Okay, so the total work done, total, okay, we plus work done from the external force just now, the pushing force, plus the frictional force, plus from your weight, and also the work done from normal force. Okay, and we found that actually our weight and also normal force, there is no work done. Okay, so therefore we can just write 0, 0. So external force just now is 7.5. Okay, plus frictional force is negative 2.4, plus 0 plus 0. So at the end, you will get 5.1 joule. Okay, so this is the total work done on the book. Next, we go to questions number 2. So this is an inclined plane. An object of mass 1.5 kg slide downward. So the motion is going downward on a smooth. When it says smooth, meaning that there's no frictional force. Inclined plane AC of the length. So the length is 25 meter. Determine the work done by the gravitational force in order to displace the object from A to C. A to C. Okay, so we know that A to C actually is S. S is 25 meter. Okay, the displacement from A to C is 25 meter. Okay, so this is S. S is equal to 25 meter. So the question asks us to find the work done by the gravitational force. So gravitational force, work done by gravitational force, actually they are referring to the work done by the weight. Okay, work done by the weight. So weight here is acting downward. Okay, and then the displacement is in this direction. Okay, so we know that this 20 degree, this one also 20 degree, and of course here is 70 degree. Okay, so we substitute into the equations where force times displacement cos theta. Okay, so since the question say the gravitational force, work done on the gravitational force only. Okay, so therefore F here we substitute mg, where m is 1.5, g is 9.81. The displacement from A to C is 25 meter. Okay, cos. What is the angle between the gravitational force, meaning the weight, and the displacement? So we draw out. Okay, I use the red pen to draw. Okay, so this is your displacement. This is the displacement. Okay, this is the weight. So angle between weight, okay, angle between weight and also displacement is actually 20 or 70. Okay, the angle between them actually is this one. Okay, is actually 70 degree. Okay, so we substitute into the equation. We substitute 70 degree because 70 degree is the angle between the weight and also the displacement x. Okay, the weight and also displacement. The angle must be between the weight and also displacement. So you press calculator, you will get 125.8 joule. So this is answer for questions number 2. Okay, next question number 3. A box of mass 20 kg move up on a rough plane which is inclined to the horizontal 25 degree, is pulled by the horizontal force. So this is actually the external force. The coefficients of kinetic frictions between the box is given 0.3. If the box is travel, so this is the displacement 3.8 meter along the plane. Determine the first one, determine the work done by the external force, by the gravitational force, by the reaction force, and also by the frictional force. So the first one, we go to the external force first, work done by the external force. Okay, so number 1, work done by F external. So F external here is given. Just now, the question said the F external in horizontal is 250 Newton. Okay, so I write the equation first. Cos theta So your F external is 250, S is 3.8, okay, cos theta. So the theta here you must refer back, you must draw back the angle between the force and also displacement. Okay, so here the diagram, the free body diagram already draw out where the normal force. Okay, so the normal force actually is the reaction force. We have a F external, okay, we have the weight, and also we have the frictional force. So the first one, this is our F external. So the angle between the F external and also the displacement, so what is the angle here? Okay, if you refer here, force is horizontal and S is in this angle. This is the displacement, this is our F external. Okay, so the angle between the F external and the displacement actually is equal to 25 degree. Okay, because S is along this line, the inclined plane, and the forces, the external force is into the right. Okay, so the angle is 25 degree. Okay, so you please draw out, okay, the force and the displacement, then find out the angle between them. Okay, so if you press calculator, we will get 861 joule. Okay, so this is number one. Okay, the second one is the gravitational force. So gravitational force here actually they are referring to the weight. Okay, so work done by the gravitational force is actually mg sine cos theta. So mg here is given 20 kg. So m mass is 20, g is 9.81, the displacement is 3.8, cos. Okay, so you need to draw out the angle, the force, meaning that the weight is going downward and our displacement is upward. Okay, so just now we already know that the angle between the horizontal and also the displacement is 25 degree. Okay, so here weight and also displacement, the angle between them actually is 25 plus 90 degree. Okay, so we can substitute into the equation 115 degree. Okay, so please press calculator and you will find that actually the answer is negative 315.1 joule. Okay. Okay, next one is the work done on the reaction force. So reaction force actually we are referring to the normal force. So work done by normal force is equal to normal force displacement cos theta. Okay, so the normal force here we don't know, okay, but we can find. Okay, never mind, because we know that the angle between the normal force, okay, the normal force and also the displacement is actually 90 degree. Okay, so even though we don't know the normal force, but when we substitute cos 90, we know that at the end, work done on the normal force is actually equal to 0 joule. Okay, so we don't need to find normal force because after we substitute cos 90, you will get 0. Okay, so the final answer, you will get 0 joule. Okay, next one is the frictional force. So frictional force here is equals to our work done, friction, okay, frictions, displacement, cos theta. Okay, so frictional force here is not given, but they give you the coefficients. Coefficients is equal to 0.3. And what is the relationship between the frictional force and also normal force? Okay, we know that frictional force is equal to mu n. Okay, frictional force is equal to mu n. Displacement cos, of course, is cos 180 degree. Okay, because displacement is upward and the frictional force is in opposite direction. Sorry, not n. Okay, in opposite direction, so is F. So we know that the angle between them is 180 degree. Okay, so we can substitute into the equations. Mu is equal to 0.3. Okay, the problem is normal force we don't know. Okay, we don't know. And displacement is 3.8. Okay, cos 180 degree. So before we want to find the work done for the frictional force, we must find out what is the value for normal force first. Okay, so normal force here, we must draw free body diagram. Okay, so I will draw free body diagram where this one will be x component, here will be our y component. Okay, so free body diagram, the first one, okay, is our weight, and then there's a F external. We also have frictional force, and last one is normal force. Okay, so remember x component and also y component. So the angle between, okay, this is the angle 25 degree is at here. Okay, so here I label it as 25 degree. Okay, 25 degree. So if here 25 degree, meaning that because the weight and the external force is perpendicular, if here is 25, meaning that here will be 90 minus 25 is 65 degree. Okay, so it will become 65 degree. So we need to resolve it because we want to find n. N is x component or y component? Yes, x is actually y component. So since we want to find n, so we use y component enough. See whether can get the answer or not. So Fy equals to ma. Okay, Fy equals to ma. So for y component, we have normal force, and then plus negative. Okay, this F external here, we can resolve it into F external. For y component is okay, I use another color. Okay, let's say I use green color. Okay, Fx here is downward and to the right here. Okay, so our y component for F external is in this direction, is downward. Okay, it's downward. Okay, so we write it as, okay, the angle is adjacent, so it's F external cos 65. Okay, external, F external cos 65 for Fy. Okay, after that we still have another force that acting downward, which is the weight. Okay, so the weight here is downward, okay, and to the left here in this direction. Okay, so it's because it's downward, so we put here just now is negative, negative because it's downward. So we need to plus negative mg cos 25 degree. Okay, so and it's equals to 0 because this box is not moving up or moving down. It's not moving up or moving down. Okay, so we know that for y component is equals to 0. So we write n as a subject, where n will equal to F external cos 65 plus mg cos 25 degree. Okay, so F external we substitute into the equations, 250 cos 65 plus mg just now is 20, 9.81 cos 25. So finally, our normal force is 283.5 Newton. Okay, so this part is chapter 4, where you need to use chapter 4 the resultant force to find the normal force. Okay, so this is actually, you must go back to chapter 4. Okay, so therefore we will get normal force is equals to 283.5, and finally work done for the frictional force is equals to negative 323.2 joule. Okay, so this is the work done for the frictional force. Okay, part B, find the total work done on the box. Okay, so as a similar like questions number 2, we just add all the Okay, we just add all the forces. Okay, the work done just now. So we have, how many work done we have? We have normal, weight. Okay, so we just total up. Okay, work done by the normal, work done by the gravity, work done by friction, plus work done by our F external. Okay, where normal is 0, work done by the gravity is negative 315.1, and frictional force is negative 323.2, plus F external is 861. Okay, so you total up, okay, all the value, you will get 222.7 joule. Okay, so this is the answer for questions number 3. Okay, next one, questions number 4 is give you the graph F versus the displacement. So the answers to find the work done. Okay, so we know that area under graph is the work done. So we can straight away use half, okay, 20 times 10. Okay, so if you cancel off, you will get 100 joule. Okay, so area under graph. So this is a triangle, so we use half times the force times the displacement, then you will get 100 joule. Questions number 5. The force F on the body varies with the displacement from point O. Okay, so we need to find the work done when the body is displaced 0 to 0.4. So we need to divide into two parts. Okay, the first part is A. Okay, the second part is B. Okay, so S equals to 0 to 0.4. Okay, we find A first. So the area under graph for A. So this is the part that we want to find first. Okay, where our work done is area under graph. Because this is a triangle, so we write half AB. Okay, where half our displacement is 0.4 and our force is 4. So therefore, if you cancel off, you will get 0.8 joule. So this is the work done for part A. Okay, next one we go to work done for part B. This is part B. Okay, work done for part B. So work done for part B again is equal to half AB. A is our displacement, where our displacement is 0.8 minus 0.4. So we just substitute 0.4, and the force here is negative 2. So we just substitute the value negative 2. Okay, so the 2 cancel off. Finally, you will get negative 0.4 joule. Okay, so this is the answer. Okay, next one is A, this is B. So just now A, we already find S to 0 to 0.4. Okay, so this is A. Okay, B is, we want to find the work done from 0 to 0.8, meaning we want this is actually total. Okay, this is actually work done on part A. Okay, so next one we want to find for B, we want to find work done, okay, total. So work done total is actually work done for part A plus work done for part B, where A is 0.8 just now and B is negative 0.4. So finally our work done total from 0 meter to 0.8 meter, total work done is equal to 0.4 joule. Okay, so this is for part A, this is for 5B. Okay, last questions. We go to questions number 6. So again, a horizontal force is applied 2 kg of radio control car as it moves along a straight track. So this is the graph force versus the displacement. We want to find the work done where the car moves from 0 to 7 meter. 0 to 7 meter. So again here we can split, okay, into two parts, part A and part B. Okay, so we go to part A first. part A is actually a trapezium. Okay, it's a trapezium. Okay, and then part B is actually a triangle. Okay, so this is actually a triangle. So we can find work done for part A, where the work done displacement from 0 to 6 first. Okay, because this is a trapezium, so the equation we use is half, okay, A plus BH, where A plus BH. Okay, where this is A and this is B, this is the H. Okay, half A is 5 minus 3, so it's 2. B is 6 minus 0, so it's 6. H is equals to 5. So we will get half 8 and this is 5. So meaning that the first part we will get 20 joule. Okay, the second part B, because this is a triangle, so it's A times B. Okay, where this is our A and this is our B. So half A is 7 minus 6. 7 minus 6 is 1. B is straight away we take 0.4. So you just substitute 0.4. So therefore, you will get negative 2 joule. Okay, but the question asks us to find the work done, the total work done from 0 to 7 meter. So we need to find the total work done, where it's equals to work done A plus work done B. Okay, so work done A 20 plus negative 2. So finally you will get positive 18 joule. Okay, so that's all for today. Thank you for watching my video. So remember to subscribe my channel and share with your friends. Okay, see you on next video on the next topic 5.2. Thank you. See you again. Bye.